this recording, we shall look at integrating rational functions that are a linear function divided by a quadratic function in the special case where the linear function on the numerator is some constant multiple of the derivative of the quadratic function on the denominator. That is, if the denominator has form b2x squared plus b1x plus b0, then since the derivative of that is 2b2x plus b1, then the numerator will be some constant k times that derivative. And in such a case, we can use integration by substitution to evaluate the integral. So let's see how this works with respect to a particular example, but it will always be the same general process. Let's work out the integral of 5x plus 10 divided by 2x squared plus 8x plus 13 dx. And the first thing we could do is we could simply rewrite the expression inside the integral sign as 1 divided by 2x squared plus 8x plus 13 multiplied by 5x plus 10 dx. So let's work out what u is by letting the denominator expression be equal to u for convenience. That is, let's call the denominator 2x squared plus 8x plus 13 u. And then differentiating that, we get du dx equals 4x plus 8 in this case. And that then means we can write this as du equals 4x plus 8 dx. And if substitution is going to work, we would be wanting to replace this expression, 2x squared plus 8x plus 13, with u, so that would become 1 divided by u, and this 5x plus 10 dx part of the expression, we would be wanting to replace that with some multiple of du. So the question is whether 4x plus 8 and 5x plus 10 are related by some constant multiple. And in fact, if we look at it, 5x is 4x multiplied by 5 on 4, and similarly 10 is 8 multiplied by 5 on 4. So that means that in fact 5x plus 10 is 5 divided by 4 times 4x plus 8. And that means that that in fact is the same as if we multiplied the other side of this equation by 5 on 4 as well. Then if du is 4x plus 8 dx, then 5 divided by 4 du is 5 divided by 4 lots of 4x plus 8 dx, which is in fact the same as what we have here, 5x plus 10 dx. So that means we can now then do substitution to evaluate our integral in this case. That is, our original integral would be replaced with the integral of 1 on u times 5 divided by 4 du. And from there it's then straightforward to evaluate. We simply bring the 5 divided by 4 outside the integral sign, since that is just a constant, and we can now integrate that with respect to u. And integral of 1 divided by u is just the natural log of the absolute value of u plus a constant. So in this case then, our final answer will just be 5 divided by 4, natural log of, and u was the 2x squared plus 8x plus 13, so substitute that back in, that plus constant c. So let's look at the general process we used here. The key part of this was to recognise that the numerator expression 5x plus 10 was actually a constant multiple of the derivative of the denominator, 2x squared plus 8x plus 14. In particular, the derivative of the denominator was 4x plus 8, and to get our expression 5x plus 10 dx, that was 5 divided by 4 times the derivative of the denominator. Hence, we were able to rewrite our expression as 1 divided by u times 5 divided by 4 du. And it was then a straightforward integration of 1 on u, giving a natural log function.